Imagine a city where analysts know a block is becoming dangerous 10 minutes before something happens. Not because anyone called 911, but because sensors, drones, and environmental data all picked up the pattern. If that sounds interesting to you, take a deep dive with me into how data can transform the field of crime analysis. To understand how this transformation happens, we can break it down into four key drivers shaping the field: the Internet of Things, IoT, ethics in big data, the economics of artificial intelligence, AI, and Amazon's shipping then shopping predictive model. I will talk about how each one relates to modern crime analytics, beginning with the biggest turning point, IoT. IoT connects physical devices to sensors that continuously generate data. That idea fits perfectly with the rapid rise of real-time crime centers. We are already seeing this play out through specific technologies, such as acoustic gunshot detection systems. These are sensors that function like urban microphones, triangulating the sound of gunfire and sending alerts faster than most 911 calls. When you combine that with drones, patrol car cameras, body-worn cameras, license plate readers, and environmental sensors, you end up with a vast network of IoT devices streaming high-velocity data to analysts. Even so, the real power of IoT emerges when these data streams feed predictive models. One of the most exciting possibilities is using IoT to automatically detect emerging micro hotspots. Imagine a precinct where the system continuously monitors pedestrian density, broken streetlights, weather conditions, and historical patterns of assault. If those factors combine in a risky way, such as a crowded area with poor lighting on a night with high temperatures, the system could alert analysts before a crime occurs. That kind of environment plus behavior plus history integration is exactly the kind of proactive strategy crime analysis is moving toward. As powerful as predictive policing can be, it only works when the underlying data is trustworthy and used responsibly, which brings us to the ethical side of analytical systems. Ethics encompasses issues such as surveillance, data privacy, and the extent to which we delegate decision making to computers. In crime analysis, the practical aspect is ensuring that the data accurately reflects what is happening rather than assumptions or outdated patterns. That is especially true when we think about how uneven data can distort predictions. For example, if sensors are deployed unevenly across neighborhoods, that affects what we think crime looks like. Ethical practice in this field entails utilizing high quality data, avoiding unwarranted trust in algorithms, and being transparent about the factors that drive predictions. That helps ensure we are policing based on real patterns in the data, not on bias. Once our data is ethical, the next question becomes how affordable prediction is, because that determines whether departments can scale these models. Prediction used to be expensive, requiring specialized hardware and large computing budgets. Today, cloud computing and machine learning tools have made prediction extremely cheap to run. As prediction becomes more affordable, police departments are more likely to utilize it. Models can continuously forecast hotspots, staffing needs, recidivism risk, or even the times of day when certain crimes are likely to occur. Instead of only reacting to calls for service, agencies can utilize predictive models to inform patrol patterns or deploy crisis teams more effectively. However, when prediction becomes inexpensive enough to use constantly, new trade-offs emerge, such as sacrificing accuracy for speed. Even so, as accuracy improves, proactive deployment becomes operationally more effective than waiting for incidents to occur. That shift toward preemptive action links directly to a concept from the private sector. Amazon's shipping then shopping strategy explains what happens when prediction gets accurate enough. It becomes cheaper for Amazon to ship items before customers order them. That is a huge business model shift. A similar shift is possible and already starting in public safety. As predictive models improve, policing can shift from responding then deploying to deploying before responding. If IoT data and forecasting cross an accuracy threshold, departments could pre-position officers, drones, or surveillance cameras in areas that they predict to spike in risk. It becomes the public safety version of shipping and then shopping. To see how this works in practice, consider a simple scenario. Imagine a heat wave hitting the city during a week when buses are running on reduced schedules. IoT health sensors detect rising temperatures around encampments. Transit data shows long delays, and past records reveal that this exact combination has led to spikes in behavioral health crises among unsheltered populations. Before any 911 calls occur, the model alerts crisis intervention teams to pre-position water, medical resources, and support personnel in the areas most at risk. It operates on the same mechanism as Amazon's anticipatory shipping, using patterns in the data to act before the need fully appears, except here the goal is prevention rather than retail. Together, these ideas point toward a future where crime analysis becomes increasingly data-driven, real-time, and predictive. IoT sensors expand the range of what we can monitor. Ethical considerations ensure we use that data responsibly. Cheap prediction reshapes how we deploy resources. The Amazon model helps us envision what policing could look like if forecasting becomes accurate enough to act on before incidents occur. Ultimately, the intersection of data, technology, and decision making is precisely why I am interested in pursuing a career in crime analysis, an area where data directly improves people's lives.